So in our graph, the x-axis is the number of times at bat, and the y-axis is the number of hits. And the relationship there is the more times you go up to bat, the more hits you have. So at-bat increases is correct, at-bat decreases is not, and the number of hits increases. B. Estimated increase in height each year. Each is a key word that tells us we're looking at slope. So there's a lot of words here, but they're just asking you to identify the slope, which is 3. This equation shows us the height of an apple tree some number of years after it was planted. The y-intercept represents the starting value or the initial value. So that's going to be the height when it was planted. So this linear function models the annual percentage increase in the population of India. And even though my slope is negative, it's always going to be an increase. So this, which is in function notation, tells you that when we are 20 years after 1990, so x is 20, that's our input, our output will be 1.376. So we don't want A or B because we want to see this part. And percentages are not cumulative, they're year by year. It's always over the previous year. That's why C is the best answer. And if we say 1.376 times, that's actually a 37% increase. So this is the correct answer. On our x-axis, we have mail surveys. On our y-axis, we have phone surveys. So if we plug in 0 for mail surveys, we can identify that there are 125 phone surveys, and the total cost is $5,000. So if I divide 5,000 by 125, I get $40. This one is about Raymond's salary, and this is our formula. The 30x is the overtime, and the 800 is his base salary for 40 hours. We know this because x is the total number of hours that he works over 40 hours. So it's the only one that has nothing to do with overtime. So as the length of the first metacarpal bone increases, the height increases as well. So there's definitely a correlation there. So the slope of this line is going to tell you the average rise over run. So it's not going to tell us the predicted height for a specific value. That's no good. And notice that in A and B, they just have the two variables flipped around. Rise should be on top, run should be at bottom, so it should be height per increase in the metacarpal. That's why A is the right answer. We have this equation here, which takes the number of square miles that are in Aruba and the number of square miles that are in Bermuda, and multiplies it by a variable in order to give us the total number of residents. So that's going to be the population density that we are multiplying by. How many residents are there per square mile? Well, we take the density times the number of square miles. So that's why D is the best choice. So this equation tells us how many cups of hot chocolate are sold. The baseline is 456, and as we plug in T, the temperature, that amount either decreases or increases. So as we plug in 1 for the temperature, the number of cups is going to go down by 3. So this is cups down by 3, and this is temperature up or down by 1. So they want to know what 3 is, and that tells us not increase or decrease of 3 degrees, but it's 3 more cups. And should it be for every one increase or every one decrease? It turns out it's a decrease because of the negative. We have two equations for different shower heads here, type A and type B. Just looking at the slopes, B, the water comes out twice as fast. And these are both linear relationships, so they're not increasing at faster rates. Those are both wrong. And B is twice as the amount as A. So that's why A is our answer. So we have this equation right here, which tells us how much Rachel spends on automobile maintenance and fuel. The $1,000 is for insurance. That's a one-time fee per year, and it doesn't change. But the maintenance and fuel changes based on how many miles are driven. So it's important to note that that's what X is. It's the number of miles. So these two answers that say per mile, those are definitely going to be correct, one of those two. And what are these two slopes, 5 cents and 14 cents? They're maintenance and fuel. That's why D is the best choice. So this equation shows us the average number of students per classroom at a particular high school, and we can see that it's going up. It started at 27, it's going up by 0.56 per year. So it's the average increase, the estimated increase each year. Those are keywords for slope. If this is our equation, we're looking for the intercept. So as the air temperature changes, the speed of sound changes. And if the temperature is 0, then this is what our speed of sound is.